It's always with great humility that I stand in front of you here. There's a lot of talent in this room, and on your shoulders I've learned a lot. So this is the night High Performance Design meets Boots on the Ground. Boots on the Ground is really what's key here. It's one thing to come up with a design and a concept, but the builders have to execute.
In 2009, we bought this derelict nightclub and rooming house in East Hamilton. The neighborhood was thrilled, and so were the cops.
We saw this building. It's exactly halfway between our office and our house. So I figure we drove by it like 100 times until we eventually just bought it.
You know, we've done point source projects. I know many of the people in the room probably have. I mean, from a strictly code compliant perspective, we need to be delivering heating to all the spaces in the house.
So my purpose here, though, the challenge was going to be the air barrier.
So one of the challenges we had with this project was how to support the brick. We wanted to have kind of a traditional look, because part of it's a church.
And another argument, I owe Robert Bean credit for this. He opened my eyes to the idea of exergy, which is the useful work potential of an energy. So
we actually put the new sheet of ply and actually wrapped the air barrier underneath, but that didn't do anything.
And then we had some really good news this week. We had our first air test.
So we need to understand when the air barrier is, not where it is, where it falls into this process. And in this next project, I'm really going to have a drop deadline.
That natural gas burns at almost 2,000 degrees Celsius, and we're using that to heat our homes to 20 or 22. It just doesn't make sense from an exergy standpoint. So we might be burning the gas in an energy efficient way in a high efficiency boiler or furnace, but we're destroying its exergy.
You know, when you're opening a door that often, maybe the air tightness of the seal is less important than sort of the functionality of the hardware.
This is 291 centimeters squared, so it's 17 by 17, and that's where we want it to be.
Every time we're doing that, burning it to heat our homes, we're denying future generations the ability to use that high exergy fuel to do things like make steel, for instance.